at the event. So, good morning, everybody. I'd welcome to this live online engineer event. Today we're featuring Vicky Howells from Thales, UK. But before we get to Vicky, I'm just going to run through what's going to happen over the next hour or so. As you can see, we've got quite a number of schools on. So we mute everybody on access. Sorry, I've just had a message from Comodo and they can't hear anything. I'll get back to that in a second. Because when you have more than one microphone open, it gets really, really noisy and quite distracting. So everyone's muted except Vicky. And the first part of the event will be Vicky's presentation, which will last about a quarter of an hour. And then we have a Q&A session where we ask teachers to type in their pupils' questions into the chat facility. Vicky will then read them out and give her answers to camera. We're booked till about 11:30. Vicky, can you go slightly over that, or do you think?
Yeah, if it comes to it, yeah.
Yeah, okay, excellent. But we'll try and get as many questions answered as possible. And after the event, please feel free to send any feedback to me, and I'll pass on to Vicky. So without further ado, I'm going to pass you over now to Vicky Howells, who is the Director of Engineering Projects for Flight Simulation at Thales, UK.
Hi, guys.
It's all yours, Vicky. I'm going to mute myself. I'm just going to...
Morning, everyone. Thank you for meeting with us today. So my name is Victoria Howells, and I'm Engineering Director for Thales, UK. It's a really big company, so we've got about 8,000 people worldwide, and more than half of those are engineers. So we're a really big engineering company, and we have engineers doing all sorts of things, so every different type of engineering. My specialism was pilot training, which is what I'll talk to you about a little bit today. And I have a 6-year-old son called Leo, who used to actually go to Burgess Hill Girls' School Nursery. So I'm very familiar with some of the people probably that are on the phone today. So I'll talk a little bit about what I do, and then feel free to ask any questions that you want to know the answer to. So I'll talk a little bit, start with about what engineering is. So at a basic level, if science is how we learn about things, engineering is about how we understand the world and the universe. Sorry, I'll start again. So if science is how we learn about and understand the world around us and the universe and how we understand things, engineering is how we solve the problems that we find. So when we look at things like global warming, when we look at problems such as how to train pilots and all sorts of different things, engineering is how we solve those problems and how we build things. So almost all of you will have come to school in some form of vehicle. You'd have gotten on a train, maybe if you're in a city, or you'll have gotten on a bus or on a car. All of those are engineers. All of those are engineered devices, and they will have had many different engineers involved in them in the development. So there are materials engineers who develop what kind of metal things should be made of. There are engineers who kind of specialize in physics and things like that. So how fast can a train go? How far can it lean over on its rails? Why can it go at the speeds it goes at? There'll be engineers designing communication systems, so the way that control centers can talk to the train drivers, how you can use your mobile phone on the train. All of those are things that engineers will have developed. So if you're sitting on a chair, that chair was engineered by somebody. And they will have taken into account how much stress, what the weight was likely to have been of the people sitting on it. And they will have over-engineered it to make sure that even if 3 people all sit on top of each other on that chair, you'll still be safe. Everything from your favorite toy, your phone, if you've got a tablet or you've got a games console, or you're used to using an app on your mum and dad's phone, all of those are engineered by different types of engineers called software engineers and mobile application engineers. So all of these things are all different types of engineers, and there's basically as many different types of engineers as you can count. Lots and lots of engineering is really creative. In my job, we create whole virtual worlds. So my job is to train pilots by designing the most realistic environment, a virtual environment like a computer game, to help those pilots react in the way they would when they were flying a real aircraft. And I do it for commercial airlines, so the types of planes you go on when you go on holiday, and also the type that defend countries and do special operations. This is a flight simulator. So this is the type of engineering that I specifically did, which is, these are big, inside there's a plane cockpit, like a real plane cockpit. So we take those from the people who manufacture the planes, we put them into these big spheres, and then we put them on what's called motion, so they can move around and they can fly the plane, and it feels as if it's moving as it would in the real world. So I'm going to show you a quick video of one of those being built.
Vicky?
Yeah.
We're just getting a blank. Well, I'm just getting a blank screen here.
Oh, I apologise. Let me. Chris, are you able to see the screen now?
Sorry, yes. I muted myself. Yes.
Excellent. Well, I apologise for that. That should have been a really interesting video of a flight simulator being built by lots of different types of engineers, but we'll have to skip past that. Apologies. So there are different types of simulation and different types of engineering that are required for different pilots and different types of aircraft. So these are just some of the types of pilots that I've helped train, from fast jet pilots to commercial airline pilots in the middle, people flying helicopters, people flying what we call fixed wing, so the type of aeroplane you go on holiday. So in the top left is an F-35, which is a very new generation of fighter jet. The bottom left is called an Atlas. So it's a really big, as you can see, a really big aircraft that carries people and things like tanks over very, very long distances when our armed forces have to deploy to other countries. But they also help in disaster situations, and they do rescue work as well, which is really important. The top right, you can see the kind of aircraft that you would go on holiday, and I've trained lots of pilots to fly those aircraft over the years. And then the bottom right is an RAF Sea King, and those are the types of aircraft that do rescue work. So the all the at-sea rescues and things like that tend to use those types of aircraft. So this is a Chinook. So I've trained people to fly Chinooks. These lift very, very heavy loads. If you look on the right-hand side, you can see them lifting up whole armored vehicles, which are incredibly heavy. So these are aircraft that are engineered for lifting. They're very, very strong. That's why they've got two propellers in part. They're also really, really difficult to fly. So it's really important that those pilots are trained very, very well indeed. This is a Sea King, as we talked about. Prince William used to fly one of these when he was doing search and rescue. And they're kind of a workhorse aircraft. They're very agile. They get put into very difficult situations. So we have to train pilots to be able to lift people out of the sea and to operate in very, very difficult conditions. This is the F-35. This is like flying a computer game. There's very few actual controls, and it's all done on touch screens like the tablets that you may be used to using at home and mobile phones. So it's a flying computer, really. So a very different type of aircraft to some of the other ones. And this is the Atlas. This is what I'm working on at the moment. And as you can see, you can drive whole lorries into the back of this aircraft. So it's very big and it's very heavy. And one of its main jobs is refueling fighter craft. So if you look in the top left, when our defense pilots have to fly very long distances overseas, they can't stop at a petrol station and refuel. They have to be able to refuel in the air. And it's very, very skilled work to fly both the fighter jet and the Atlas in order to be able to refuel in the air. The hose that they're trying to connect is only about that big, and they're doing it in the middle of the air with all the wind and all the physics forces around it, which makes it incredibly complicated to do and very difficult to train people to do well, but really interesting work. And we've talked a little about the types of aeroplane you go on holiday. These are more heavily computerized now. So we have a lot of things like autopilot. So the pilots really only do the takeoff and the landing now, and the computers kind of take over in between. But even so, it's very important those pilots are trained really, really well. I've also worked with NASA, not specifically on the space shuttle, but I did put a rocket on here just to make sure that everyone knew what NASA was. But pilot training for landings and deployment is really, really important, and then being very familiar with the bases that they're going to land at. So we have worked with NASA as well. So a virtual world is basically like a massive computer game. It's an environment that pilots have to, what we call willing suspension of disbelief, which means they have to believe they're operating in a real environment so that they behave the way they would in the real world. This is an image of one of the airports we build, and what you'll be able to see is it's made up of lots of little lines if you look at it closely. Everything you can see there is made up of what's called a polygon, which is a triangle, a 3-point triangle. The clouds are even made up of triangles, so it might be hard to believe. And this is how we create our scenes. So we have people who are very artistic as engineers who develop this type of content, and that was my background as well. We have people who are developing physics models, people who are doing computing, people who do what we call image generation, so the computers that render these images. And we have to do it in all types of day and night. So we have to do what's called diurnal effects. So you have to be able to tell what time of day it is from the position of the sun in the sky. So you should be able to tell that this is a dawn type image without anybody really telling you because of how the sun is being cast. And yes, so that pilots forget this is a real world, forget that this is a virtual world. Again, if you look here, you can see that everything, the planes, the markings on the ground, the clouds, the buildings are all made up of these little polygons that we create in order to paint a picture effectively of the scene. This is one of my favorites. We have to train pilots to fly in all different weather conditions, and snow is particularly difficult because it creates very specific effects. And for example, you will much more likely skid on the runway. So we have to have physics models that allow the planes to react in certain ways when they hit the ground if there's a picture of snow on it. So that's complicated and interesting work. But again, really, really important for training those pilots so that if they land on an airport with snow in the real world, they know exactly how it feels and exactly how they need to respond. That's the end of my slide.
So everybody, lovely, brilliant. Thanks again, Vicky. So I noticed you had Sunny Williams on one of your photographs, who the NASA astronaut.
Yes.
Yeah, she did one of these events last year.
Oh, fantastic.
Yeah, she was wonderful as well. Excellent. So everybody, it's Q&A time, and as I mentioned before, if you can type your pupils' questions into the chat facility, making sure that the little drop-down box above where you type it says to everyone. Yeah, type your questions in there, and Vic will read them out and give her answers.
Oh, there's some really good questions. Okay, what inspired me to become an engineer? Actually, I didn't know I was going to become an engineer. It kind of chose me. I studied art and design. I did a degree, and then I did a master's degree, and I did some computer generated design on my master's. And a company that did flight simulations saw it and asked me to come for an interview. Actually, if I look at it, I just like problems. I really, really like problems. And as I've kind of gone through my career, I've gotten to tackle bigger and bigger problems. But I think one of the things I really want to make clear to everybody is you don't necessarily have to have studied engineering to be interested in engineering, or even to get into that career. There's lots of ways of doing it. I did a degree in multidisciplinary design and then a master's in product and industrial design, which is how I eventually got into it. But we bring people in through all different routes. We have apprentices who come in straight out of school, who have a brilliant time and get to do loads of different things. We have graduate apprentices who do degree as well as working. And then we have graduates, people who come straight out of university. So there is a million different ways, or at least 3, of getting into the type of company I work in, or engineering, that suit all different types of people with all different sorts of skills. Where did I study? I studied at Brunel to do my undergrad, and I studied at Liverpool John Moores to do my master's, and I've just done a postgraduate degree at Oxford. So I'm rich in degrees now. That was in answer to Burgess Hill Girls' School, where did I study? Have I ever flown a plane? No, I actually really don't like flying. Ironically, and maybe because I spend so much time in aircraft, it's just not my favorite thing because I don't feel in control. I've flown lots and lots of flight simulators. And if I'd wanted to get my pilot's license, it would have been quite easy. But no, I much prefer kind of spending time with my little boy, or going horse riding and reading and things like that. But I really enjoy flying the simulators, because that's enormous fun, and you just get to fly every different type of aircraft you can imagine. What's the biggest aircraft I've ever worked on? That's from Banterskin. The A400M, the Atlas that I'm working on now, is by far the biggest physical aircraft, and a really interesting aircraft because it has so many different operations, and that's a really interesting one to work on. How much money do you make per year? I make quite a lot because I'm engineering director. So I would say over £100,000, but I won't tell you exactly how much. Why did I want to do this job? How many people have been on your simulation? So the simulators, because they're expensive to make, they're in use 24 hours a day. So pilots are training on flight simulators 24 hours a day. They have very little downtime. They will go in, they will train on the skill they need, and then somebody else will come in an hour later and train for the same skill again. Pilots have to train, they have to train on a flight simulator in order to get their accreditation, because you simply can't get enough live flying hours just by flying an aircraft. So almost every pilot you will ever meet, unless they only fly very small personal aircraft, will have flown a flight simulator for a good amount of time. How long does it take to build a flight simulator? So that's a really good question. If you have to do one from scratch, so you're writing all the software, you're developing all the hardware, so anything physical, if you're doing all of that from scratch, a totally new design would probably take 2 or 3 years. Just if you've designed it and you're putting it together, which is what the video should have shown you, you can probably do that in about a week. What's the favorite, well, your favorite thing that you've engineered? Oh, interesting. What's my favorite thing that I've engineered? I'm really enjoying the Atlas work, I think, just because it's a really big, really important aircraft. And we're working a lot with the RAF, who are really impressed with it. So that's really interesting. I like doing difficult things. I like things like air-to-air refueling, where you've got lots of unpredictable elements that you have to try and engineer solutions to. So I like that. Is there a sea otter simulator? Yes, there definitely is. How does it feel being the boss? Being the boss rocks. So I would say that there's lots of good role models in engineering leadership. Whatever your background, you'll find an engineering leader who's got something similar to you. I think because we're bringing people in from all sorts of pathways, we're getting more and more diverse and more broad. And I personally feel that engineering flourishes when it has a lot of different voices in the room, and that requires a lot of different backgrounds and a lot of different experiences and all sorts of things. So we are stronger, we will have better engineered solutions, more elegant solutions, the more voices we include. How long does it take to fly a pilot, train a pilot? So you can train to be a pilot of a very small light aircraft quite quickly, and you could probably do it in 6 months to a year. To be a commercial airline pilot takes a long time, and you have to do a lot of different types. But they do what's called ab initio, which is Latin from the beginning. So now airlines do take people who've never flown an aircraft before and will train them all the way through until they start taking people on their holidays. And that can take 2 or 3 years. Can I fly? No, I know what all the controls do. But yeah, no, I don't want to do that. What age did I become an engineer? Straight out of my master's, so I was 23. How do they build the simulators? Well, we have a lot of different engineers who are involved. So we have installation engineers, hardware engineers, software engineers, systems engineers, synthetic environment developers, geographers. There's an enormous amount. And I think if you take anything away, is that the breadth of engineering is enormous. Almost any problem that you're trying to solve has got an engineer in amongst it somewhere along the line. How long does it take us to do one project? It's a really good question, but it's a tricky one to answer. So our A400M program will be about 10 years because we're delivering 10 different training devices all over the world. The aircraft is quite often being developed at the same time as the training. So we have to wait for different stages of the aircraft to be developed for us to be able to put that, what we would call functionality, into the simulator. So it's something what we would call parallel development, which makes it quite complicated. How does it see feeling pilots being fully trained? I absolutely love it. It makes me feel like I'm contributing to people being safe and to countries being able to sort of defend themselves, and it feels valuable and important. It makes me happy. How many flight simulators have I ever made? I have probably been in the delivery of about 250 flight simulators over my career. Is my job a fun job? Yes, it's awesome. It's really, really good fun, and I love it every single day. Engineering is sometimes seen as a man's job. Did you find it tough choosing this as a career? Absolutely not. I've never had any issues. I am quite often, at my level, the only woman in the room, but I've never suffered for that. And I have got lots of role models ahead of me, women in engineering. And we've got a fantastic pipeline of incredibly capable engineers, male and female, coming through. So I think it may have been seen as that in the past. I don't see it being an issue now, and it's certainly never been an issue for me, and I've been in engineering for 20 years. Do all airlines use your simulators? They all have to use simulators, but they may not have bought them from the company I work for. Has there ever been a serious malfunction? On a flight simulator, the most serious thing that can happen is the motion fails. So that could be quite dangerous. If a flight simulator sort of up in the air and it would never actually hit the ground, but you would get a horrible shock from it. That's about the most serious thing that you could have that would happen. And how large is your team when you're building an aircraft? It probably takes maybe 100 different engineers of different skills to build a flight simulator. And I've got about 300 in total, so I've got plenty to choose from. Oh, hang on, sorry, scrolling down. What project took the most time to build? That's a little bit like the previous one. It really depends on how the program's sort of scheduled. What do you need to be good at school to become an engineer? Be curious. That is basically the skill for an engineer, is be curious. And I'm going to use a big word now, tenacious. So be willing to keep poking at something till you get to the bottom of it and find out why. If you're somebody who asks why a lot, you'd make a fantastic engineer. Do people ever get sick in flight simulators? Yes, all the time. It's something they do what's called aversion training. So sometimes even people who've joined the RAF will actually get sick, and they'll need to spend lots of time in flight simulators and lots of time in real aircraft in order to get over their sickness. It's basically like a muscle. They just have to kind of exercise the muscle, and eventually they get over it. Is it hard? Yes, there's lots of bits of it that are hard, but if you're good at it, you find it easy, which is the interesting thing. So I've got lots of engineers who are much cleverer than I am. I've got lots of engineers who do things I could never do, but I'm good at one particular thing and they're good at their particular thing. So it's about finding the thing that you're good at, and then it's not hard. It's only as hard as you make it. How long did we work with NASA for? We worked with NASA for a couple of years on and off. How do you solve the problems? Do you always get it right first time? No, absolutely not. Engineering is very much trial and error. We do lots of things to try and make it more likely that we might get it right first time, things like testing and things like that. But no, you'd be a very frustrated engineer if you needed everything to work right first time. So we bake lots of time in for testing and going over things and having to redo. And sometimes we have to just start again from the beginning. And I've been in charge of projects where we've just had to go, nope, this isn't going to work, and go back to the business and say, I'm sorry, we're going to have to start again. And that's fine. How much of your work is on your own and how much of it is with a team? So almost everything I do that's proper engineering is with a team. And for the most part, we have a structure. So a bit like your headmaster and your teachers, and then you and your class. So if you think of me, I'm a bit like the headmaster, and then I've got some amazing teachers who are in my organisation who are all very specialised in their own discipline. And then we've got people who work for them who are very capable as well. So all day, every day, I'm going into a different room and looking at a different problem with almost certainly a different set of people. So it is never, ever boring. Why did you decide to do this presentation? Because I think it's really important that people understand that engineering is pretty much everything. And I saw a lot of people when I was at school thinking science and maths wasn't for them, particularly girls, and it feels important that that's corrected and that people don't feel that way anymore. And because I have a 6-year-old and I think children are awesome. Does engineering make your day a better day? Absolutely. I love knowing how things work, and I'm just a curious person. So if I was in a job where asking why wasn't encouraged, I think I would find that very difficult. Where did you do your training? So as I said, I did a degree and I did a master's, and then I did on-the-job training. So I learned to be an engineer by being an engineer and learning from people who had more experience than me. I work with so my team is about 300 people, but the bigger company is about 80,000. What's the most important thing to remember when making a simulator? Make it feel real. That's the absolutely most important thing. Anything that's too perfect won't make it feel real. So it has to feel like the real world. People have to almost notice nothing. If they notice things, then that's breaking their sense of realism. When do you get a break and go on holiday? I go on holiday lots. Yes, I get lots of holiday. So I take my little boy skiing, which is really good fun, and then we go on holiday and go to the seaside and do all the things that you guys do as well. What's the best part of my job? When we solve a big problem. When we didn't know the answer, and then by working together as a team, we got to the answer. That I completely love, and I just think it's really brilliant. Do I want Leo to follow in my footsteps? He says he does. I want him to do whatever he's good at, not just because I'm an engineer. He shouldn't have to be an engineer, but he loves engineering, and he's very interested in climate change. So I think he will be very interested in those kinds of problems as he grows up. What was my favourite subject at school? Art and English. Really not traditional engineering subjects at all. So no, do you want to know a secret? I got an E for GCSE science. That's my terrible secret. So yeah, try hard and be as good at it as you can do, but nothing's the end of the world. And if you're capable and interested and curious, there'll be other opportunities. What's your favorite part of making the virtual world? When people can't tell the difference between reality and the virtual environment. I once had a virtual reality environment we created of Toulouse in France. And I got a question from a pilot, and I sent him a photograph of the real world, and he sent it back thinking I'd sent him a picture of the simulation because it was exactly what he could see out of the simulator window. And I was so pleased. That's my best compliment ever. Is he was confused and he thought that was the real world, was the simulation. Sorry. What's the most dangerous thing about being an engineer? There's nothing really dangerous about being an engineer, as long as if you're a hardware engineer, you've got your steel toe cap boots on and your high-vis vest. Those are the important things when you're operating in those types of environments. Did the teachers at your school help inspire you to become an engineer? I think they inspired me in different ways. I don't think anyone thought I was going to become an engineer. I think they maybe thought I was going to become an art teacher. They inspired me in different ways. They encouraged me to be curious, and they encouraged me to ask questions, and I think those were very valuable skills. Do pilots get scared on the simulators? Yes, and that's kind of the point, because if they're going to get into a situation in the real world where they might be a bit scared, I would much prefer that they practice on my flight simulator first and learn to overcome that fear, because they know what they're going to do in those situations. No, I don't know how to fly an aeroplane. Are any of your planes solar powered? Nothing. I haven't trained anyone to fly a solar powered plane, but that is increasingly becoming. I had to write a paper recently, actually, and I was writing about the need for increased training as technology changes in aerospace. And I think that's one of the things. I think you're absolutely right. As new technology comes through, new ways of powering aircraft, there'll be more and more of a need to train people more and more rapidly on different types. what would I change about my job? I'd have more money to do the things I want to do. In engineering, you can always do more, but there has to be a limit. And so sometimes I run out of money before I'm entirely happy. So that would be nice to have an unlimited bucket of money to spend. Yes, I get to go in the flight simulators a lot. At the moment, how long were you an engineer before you made your first simulator? So I worked on the synthetic environment, so the virtual reality piece, almost straight away. So I'd been an engineer about 10 minutes before I started working on that. I had been an engineer about 10 years before I started working on the bigger parts of a flight simulator. If I had to choose a different career, what would it be? Quite like to be a politician or maybe an academic. I like talking. I like persuading people, which is good in engineering, and I think it would be quite good as a politician as well. Which aircraft is the difficult or hardest to engineer? That's really interesting because things are difficult in different ways. So some of the older types of aircraft that are very physical, that's difficult because it has to feel just like the pilot thinks it should feel when they're flying. So it should, turn left, turn right, come up, come down in exactly the way they're expecting it to feel. The ones that are more computerized are harder because they're just more complex systems. So they're all challenging in different ways. How many materials are involved in making a simulator? I don't know. It's a fantastic question. I would say it would be in the at least about 500. A lot, an awful lot. Do you get to go to other countries as part of your job? Yes, I've traveled all over the world doing pilot, not personally training the pilots, but getting simulators ready to train pilots. I've traveled all over the world taking pictures so that I can build those worlds in my synthetic environment. Yes, I had a lovely time traveling all over the world earlier in my career. Do you have many dyslexic engineers on your team? I'm so glad you asked that question. One of my chief engineers is dyslexic and severely dyslexic, so he has to have his emails read to him by a computer program, and he is an absolute genius. So yes, we quite frequently, in fact, we have a higher incidence of dyslexia in engineering than in many other disciplines because of the critical reasoning and problem solving skills. So yeah, lots and lots of engineers have dyslexia across, obviously the whole cohort. Did playing computer games when you were younger make you think of becoming involved in design? Probably a little bit, yes. I'm going to show my age now. Computer games weren't really a big thing until I was at university. But actually, my parents bought me a computer when I was really, really young, when computers first came out. And I don't know why they did it, but I think it always made me feel like I wasn't scared of computers. So I used to make lots of little animations on computers and things, even when I was very little. Have any of my simulators ever crashed? Yes, but not physically. So a bit like a software crash when your phone restarts itself or your computer won't turn on. What do you think your team would say about you as a boss? I think they would say I was firm but fair. We're currently debating who invented the light bulb. Well, Thomas Edison took the credit. I'm not sure he developed. So this is a really interesting topic. So the light bulb is really a product of the innovation of the electricity grid, which was the product of other people. So yeah, I know the answer is meant to be Thomas Edison, but I don't believe it is. Are you going to do something exciting in your work after this video ends? Yes, I am going to do something interesting. I'm going to go and talk to some people from the RAF about what they need in the future. How long does it take to build a simulator? Again, anywhere from physically just probably about 3 weeks. Has any trainee quit after using a flight simulator? Yeah, I'm sure they have. Do you spend a lot of time looking inside real planes? I did earlier in my career, definitely. I spent a lot of time at air bases, military ones, a lot of time at commercial airports, going around and taking photographs of everything. It's very weird. You feel very, very tiny when you go what's called airside at an airport. So obviously you're used to standing in the terminal looking out. When you're standing on the ground outside that building, the planes are huge. Everything's enormous. You don't realise how big it all is when you're on the ground until you're on the ground next to it. You said you were a little scared of flying, but do you wish you could fly a plane? Yes. I think I think if I could do it without worrying about it, yes, it sounds like fun. How long does your working day usually last? So I come in at 9 and I leave at 4:30. So I take my son to school and I pick him up after. So I don't work mega long hours or anything like that. Also, your signal went and you missed the light bulb answer. Not Thomas Edison was my answer. Actually, I think the innovation was in the electricity grid that allowed the light bulb to become the standard. But yeah, no, not Thomas Edison, who just took the credit. Are there any games that children can play that gives you an insight into flight? But yes, Microsoft Flight. There's lots of free games on the internet where you can have a look, and it will give you an idea of what it's like to be a pilot. Can you describe your hardest project to date? Ooh. The hardest project I had to date was about 2 years ago, when I had to tell the company that they'd invested an awful lot of money in something that wasn't going to work, and we had to start again with a lot of very upset people, which then turned into a success, but at the time it was really lumpy and really, really difficult. I'm glad everyone agreed with not Edison. Is there anything you have made that you can make at home? I make all sorts of things, and I'm an enormous fan of Lego. Enormous fan of Lego. I like a Lego Mindstorm as well. Anything that I can put a motor in. So we do lots of Lego at home. I also like doing woodworking and things like that. I would say if you want to, things like little mini hydraulics, you can get little kits to play with at home. My son's just built a little robot iguana. It was a little kit with a circuit board and all those kinds of things. So I think there are lots of things like Raspberry Pi. There's all sorts of things you can do at home that are not very expensive, where you can start to play with the basics of engineering. But honestly, Lego is engineering. Don't underestimate Lego. Do you think the design of simulators can be transferred to any real world types? Yes. So I also run a team that's doing training, simulation training for tank drivers. And we're looking at doing train drivers as well. So yeah, so we're looking at how we can apply it to different people. And when my family's supportive of me becoming an engineer, absolutely. They just have the supportive as long as I'm happy, and engineering makes me very happy. What's the easiest aircraft to make a simulation for? Probably just something very simple, a very small aircraft that can land on grass or something like that. There are some countries in the world, particularly in places like Papua New Guinea, who have more airports than roads because it's such a steep, the geography is so lumpy and bumpy. So you have some very small, simple aircraft in those types of environments just land on grass runways. And those are probably the simplest type. My son does think my job is cool, yes. Yes. He likes coming in and having a look at the flight simulators. He thinks it's awesome. Where do you create the simulations? So the simulations are created on computers, but we have a manufacturing building next to ours, which is where the physical big simulators are all built. And that's just next door, so I can walk over there any day and go and have a look. What's your most recent project? The A400M Atlas is the thing we're working on at the moment. Can you describe how the plane's fuel is filled up in the air? We don't understand how the wires are connected. Excellent, really good question. So the little fighter jet has a big hole that comes out of the front with a little pointy end on it. And what comes out of the back of the refueling aircraft is an enormous long hose with a little basket on the end. It's called a drogue. And what has to happen is the pilot has to line up that little pointy with the middle of the drogue, and then it's like a fuel cap. So it's like you know when you put the petrol in your car, and then the fuel goes down the hose from the big aircraft straight through the pole and into the fuel tank of the F-35 or the GR4 or something like that. It's an incredibly complicated thing to do. Really, really interesting. You can find lots of videos of people doing air-to-air refueling on YouTube. It would be worth a look. It's very clever. If I could do a different job, what would it be? Maybe a politician or something like that. And is there anything that annoys you about my job? Only when people aren't ambitious. The only thing that really annoys me is when people don't try to come up with new solutions and they just say things like, this is the way we've always done it. That makes me grumpy. What's my favourite hobby when I'm not at work? Playing with my son, horse riding, and things like reading. If you could give one piece of advice to our class about becoming an engineer, what would it be? Ask why a lot and keep asking why. It's a really important skill. And then just be curious, be interested, read about things. If you want to know how something works, find a book, ask Alexa, type it into Google. It doesn't matter how you get to the information as long as you're trying to get to the information. Do you have a pet? No, because I'm not in my house a lot. So sadly not. My son would really, really like a cat. We have to go. Bye. Did you like planes when you were little? Yes, I liked anything that moved, anything that had an engine or something like that. I just like things. I had robot toys when I was younger. I just like things that move. I think that's the end of the questions. Oh, do you work on the weekends? Oh no, sorry, there's one left question. Do I work on the weekends? Very, very occasionally. I try very hard not to.
Okay, so that's like if the questions have dried up. So thank you all. First, thanks to you, Vicky. It's wonderful. Again, some great questions and some great answers as well. So thank you very much. Can I just say, as a cat owner who doesn't isn't at home much, cats are great on their own. They're fine on their own.
Don't tell my son that.
Okay. Anyway, so thank you all very much. I think we'll close down the meeting now. Thank you everybody for participating today, and don't forget, get your entries in. Get the brain working on those inventions. Get that illustration done, and teachers get those entries in. So thank you all very much, and we'll speak again soon. Thanks, Vicky. I'll see you soon.
Bye.